Anyways, okay, I started recording just for fun. Um, Math. I should get back to that. Um, why have I been doing this if I haven't been recording? Anyways, a dot product. So the product of u times the vector of v equals uh 1 times 5 plus 9 times 6. That is equal to -5 plus uh 56. No, 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 no. That's 54. I math. That is equal to 49. Yes. Anyways, it doesn't matter. That means since it's positive, it is acute. Okay, so now determine the product between a vector of magnitude 8 in a direction of. Okay. So since we have two dot products with directions, so this one is going to be like direction 300, and this one's going to be um, it's going to be direction 135, which is more like over here. If I can draw a line, and we are just going to find the angle in between them, which would be three. We can just do 300 degrees minus one minus 135, and the angles actually can be over here. Equals, and then that would just be 165 degrees. 165. And on dot product time, formula for dot product on, I forgot what this form was called. Yeah. Okay, my mind's blanking. I forgot what this form was called, but it's the one where they give an angle and magnitude. Um. Anyways, so the way you calculate this is um the magnitude of the first angle, which is 8. Here, I'll just write out the formula. Uh, Magnitude of A times the magnitude of B times cosine of theta, which theta being the angle in between them. So we can just multiply it. So we got 8 times 2.6 times cosine of 165 degrees. Throw that into the calculator. Let's go here in degrees currently. So we go 8 times 2.6 times cosine 165, and we got -20. So as we all know, it's negative, so that means the angle is obtuse. But we already know that. So not really much more to say. -20.091257119. That's the number. Okay, determine the dot product between a vector with a magnitude of 18 and in a direction. Why am I doing this? Okay. So we can do what we did above and take the difference of 3, and actually, um, the difference between these two are the same as these two because they're just these plus 10. So it's going to be 165, but we should drag that anyways. We can just go 18 times 22 times cosine of 165 degrees. We throw that into the calculator. 18. Am I writing it like this? 18 times 22 times cosine of 165. You get negative 1, negative 382. 0.506627 So that's math. Okay. Determine the angle between two given points. Okay, so there's an angle between those points. So what we can actually do, since we have two dot product calculations, um, u v equals, um, so we can just set the two dot product calculations equal. So we go, u1 times v1 plus u2 times v2 equals, um, the radius of u times radius of v. Okay, I think my voice is slowly starting to go out. Times cosine theta. So that's something. Because both of these equate to the dot product. So now we just put in our values that we have, which are the ones on this side, and we can calculate these two and just do inverse cosine to get theta. So we can just do this all at once, for dot product. We can do 6 times -5 plus negative, or yeah, 6 times -5 plus 2 times -7. We can do 44 equals the radius, or the magnitude of that cosine theta. So we can actually calculate these two magnitudes. This equals square root of 6 squared plus 2 squared, which is equal to the square root of 40. Now, for v, we can just do square root of 5 squared plus 7 squared equals approximately 25 plus 49, which would equal 74. That's good. I'm gonna double check that because I'm tired. Yep, got that right. Now we go 44 over uh, root of 40 times the square root of 7 times the square root of 74 equals cosine of theta. So now we just go cosine inverse of 44 over 40 times 74 equals theta. I'm starting to get slightly lightheaded. Wow, have fun. This is why I don't normally talk when I do math. It's gotta be square root. That is in degrees. I think it should be fine. It doesn't say you have to do radians. But also, that is also incorrect, if I'm not mistaken. Wait. Yeah, because. Okay, 1 second. Anyways, what are we doing? Oh yeah, as I was saying, I don't think that's correct. The reason is, for one, we know it's obtuse. Or no, we know it's cute. Wait, if we know it's cute, I'm gonna have to check my math here. It is 30. This is not 44. It'd be, oh, it's negative 44. Yeah, it's negative 44. What am I doing here? Okay, that answer seems a lot more possible since we know it's obtuse because it's negative 44. So, we got equals 143.972 degrees. That's what I'm going to. Um, time to do the same thing again. So we have. I'm gonna go get some water before my head explodes. Okay, back to math. Okay, I got some water. That was better. So we go 3 times 9 plus 9 times 9 equals setting up the same formula we did before. And then we can calculate the magnitude equals square root of 18. Yeah, I can just, that one's, you don't really have to write it out. For V it is, so for V it is square root of, so it is 9 squared, which, so it's just square root of 90. So we go 27 plus 81, that is 88, no wait, equals, square root of 18, 90 times cosine theta 108 root 18 90 equals cosine theta cosine negative 1 no 108 over 90 um equals theta cosine negative 1 108 we're going to be getting this in degrees square root of 18 square root of what did we say 90 you I forget net negatives. Yeah, something's wrong with my domain. Root of 90, that's correct. Okay, so it just keeps airing out. Let's see. We'll check everything. 108. Yep, it is 2. Problem is, yeah, I agree. It is in the domain of cosine negative 1. Hmm. Oh, wait. Oh, okay. This is my bad. I did 3 times 3 and 9 times 9 instead of oh, these two are supposed to be series. Okay, that makes a lot more sense. So it's not 108. It is instead it is 2 times 9, 27 plus 9, 36. Okay, so it actually did work. 36, and I got equals 26.565 degrees. We'll just go through decimal place. I don't know why I'm choosing 3. Next page. Do I really wanna? Okay. A question like this one has me just okay. Just like actually. Okay, give me a second. I gotta bang my head up against the wall. I mean, it's not hard. It's just tedious. There we go. My head's been banged. Okay. Okay, that one. Here we go. 1, 2. This is A, and P is at 2, 7, 4. Find the angle at point B. So what we do is we just assume everything's pointing away from B, and we find its angle. So we know this vector right here, call it vector, let's call it vector A. That is, we call this other vector vector B. No, let's call it 3 because it's heading to point C. I start stapling this pencil. I don't know where I got this. What? Excuse me? This, I don't remember where I got this, but okay. Um, for vector A, we can say since it is minus 1x, we can say -1, and then -7 or -3 from B, so we can say -3, and then we can say vector B is equal to um we can say 2 -5. So the magnitude of vector A is square root of 10. Magnitude of vector B is square root of 24 plus 25, 29. So next we find the dot product. which is negative 1 plus times 2, which is 2, and plus 15, 17, 13 over, wow. Mm, okay, so we got that. That equals cosine theta, as we previously did multiple times. Calculator. Should also study for Spanish. They call this a calculadora in Spanish. Don't think anybody asked for those guys. Yeah, got that. That ain't no way that's in no, that can't be degree. What? Huh? Guys, this is scaring me. This isn't degrees. What? That's not 3.3 degrees. That is also not 3.3 radians. Hell? That part. Let's check that. Negative 2 plus negative 2 plus 15. That's meant to be 13. My bad. I'm tired. I am so very tired. But I shouldn't be complaining. Um, that equals that theta, so that equals 42.36 degrees. Very fun. That makes sense. Object full to the top 30-foot ramp. Work. Oh god. Hell, hell no. What's the length of the ramp matter? Hold up, I'm gonna do a tiny bit of quick research. AKA looking at class notes. Because I am too tired to remember what work calculations was. I think at the test I just like completely ignored it because I didn't remember what work was. Probably wasn't the best idea. That's just not you. Um, that's required. Okay. I find these class notes. I am mumbling. I do not know how I sound. I'm gonna listen to how I sound real quick. Um, yeah. Okay. Okay, it didn't sound that bad. Wow, a lot of notes going on here. What do you mean can't load file? Yes, you can. Guess I gotta look it up. Oh, so it's not just a dot product. Wait, no, that's two vectors multiplied together. Oh, yes, it is just the dot product. Okay, that's a relief. Okay, I thought that was worse, if I'm being entirely honest. Um, so we could just multiply the vectors together. So just take the dot product. 30-foot ramp. There we go. 30, 20 degrees. The ground. Very, very flat. Um, yeah. I'm just thinking that in pounds feet translate directly. So it's just going to get okay, yeah, it's random just 80. Sure, that's 80. And this angle relative to the ground is 30 degrees. So the difference in angles, say that equals 10 degrees. Or equals um 80 lbs times 30 feet. You can tell this is the American education system because they use pounds and feet. Um, don't know. I don't really like it that much, but oh well. I actually do use centimeters and grams a lot more often. Times cosine of 10 degrees. Oh, we get a dot product. Equals 80 and 30 times cosine of 10 degrees equals 32363 F foot pounds. I don't know how that works. That's their answer. I should include decimal places. Okay. Large boulder is dragged to a new position. If pulled directly horizontally, order a boulder would require 400 pounds pulling force to move. So we just divide it by the difference of, we just go 400 over cosine of 15 degrees. That is going off the other calculation that we can do. We can calculate the amount of force put on it, uh, which is this vector right, this line right here, the distance. That since we had the degree measure right here and the length right here, which we know is 400, we know that 400 times the cosine of 15 degrees equals the length of this edge, which is how much force is actually being exerted on it. So yeah, 400 pounds of force would only equate to cosine of 15 times 400 of actual force to move the boulder. So instead, we divide, which will give us the amount that we would need multiplied by cosine to equal 400, which is what we need. That was a horrible explanation, but it should be right. And that is equal to 414.1104722 LBS. Or math. Have fun. We're on page whatever we are on. Okay, break time. Dang, it's like so tempting to read another thing of silica gel like I did in the last video. So tempting. Sheet glue. Or I could eat uh unhardened but mixed silicone. Hmm. Decisions, I guess. Back to mouth. Rectangular form? Is that what they call it? I did not know they call it rectangular form. So we just solve for t, just like they want us to. So let's solve for x. Solve for this one. And we can do x minus 6 equals negative 3. Yeah. Negative x minus 6 over 3 equals t. we could just say y equals, and then we go n minus, um, there would be actually be plus, and it cancels out that. Which we can actually simplify to, uh, so then we know -6/3, that is just -2. We can just go like 8 plus x/3. That should work. So time to solve for x, or solve for t. So I don't think I want to solve this. Just oh, why, but why? Why? That's how. Let me look at class notes on how to do this more efficiently. Except I can't view any of the class notes. Okay, so I just realized they don't my teacher doesn't seem to really care about how simple the answer is. So I'm just gonna do it a pretty lazy way. Just gonna solve the y. So t equals y minus 2. And then I substitute in x equals um, y minus 2 minus um, y minus 2 to the power 4, which I'm not solving. I'm just going to call that the answer. I don't want to do this. Now these, I did them really weirdly on the test. Okay, so the way I'm going to do these, x over 4 equals sine b y minus over 4 of y over 5 the sine of t. We can do x squared over 16 equals cosine squared t, and then y squared over 25 equals sine squared t. And we can set, then we can add them together. Since these are equal, these two added together equal 1, so x squared over 16, all right, let me check camera, plus I squared over 25 equals 1. I froze. Okay, same thing. So x over 3 equals t, y over 6 equals, that is not fine. Wait, what? Oh, wait, no, that doesn't matter because this is cosine. So x over 9 equals sine squared t, y over 36 cosine squared t, x over 9 plus y squared 36, 1. That is done. So here we have to do stuff. Yeah. How are we going to make this work? We can have, since 1 equals, we can have it equal sine squared t cosine squared t. And now technically, since these both cycle differently, it doesn't matter which one we assign to which. We can just do squared over 9. Yeah, yeah. Which do square root of each one equals 9 t, and then y over 3 equals 9 of t. That's cosine. So x equals 2 cosine of t equals 3 cosine of t. That's good. Okay, now same thing. Sorry, I had to pretend to stop see if I got a glimpse of question below. I don't like that. That is not good. Anyways, stop thinking about that. Drop chicks. Get rid of those. Okay, is my recording time? 52 minutes. Oh shoot, it's too focused. How long has it been like that? I like closing one. Without having changes whatsoever. Um, okay, see if I can fix this. Oh, here we go. Manual focusing. There we go. That's good. Shouldn't be focused right hand, but the math it should, which is the really important part. Yeah, I don't like this. I think we did learn about this though. 1 second. I mean, we could just say, Since we know there's only one, we input a y value and you get an x. You could just say y equals t. And so x of t equals, you just say y of t equals t, and then equals square root of t, do t. That works. I guess if I want the equation to parametric, we could just say x of t equals t, raise the camera, xt equals t, I of t, cosine t plus 1. There we go. Wait, is that actually the final page? No way. Okay, so we got one more page left of pain. I've been recording for 58 minutes, but I've been doing this for an hour and 25, and I'm still not done. Wait, I already partially did this. Okay. So first off, I don't know why we have r equals 3 here, but we do, since we already have this, x squared plus y squared equals 9. That's a good start. But first off, good job. First off, we need to, just to make this a bit easier to use, actually, you know what, right. And for this, we can, now we can just go, I know what to do. Y equals, since starting here, just go 3 sine t, and then x equals 3 cosine t. I think that works. I don't know why I started with y. I'm gonna start with x. Oh, okay, almost done. Sorry. Um, x equals, we just go 2 cosine of t. Y equals 2 sine of t. For this is where it gets interesting. For this, you, since x stretch 2, we do x over 4 squared plus y squared equals equal to 1. And we do x equals 2 sine cosine t, sine of t Now for this, we do against 3. First we do x over 4 squared plus y over 9, for that equals 1. Okay, now we're almost done. X equals 2 cosine t. Y equals 3 sine t. Okay, we're finally done. It is just an hour and 2 minutes, and I have no idea why I recorded this or decided to annotate to like commentate on it. I'm also in a Discord call just in case anyone wanted to pop in. Nobody did. I'm disappointed in them. How dare them? Anyways, yeah, that has been math. I have no idea why I did this, and my voice is like about to die. Okay.